I have two hydrogens, like in this case, and both are equivalent, I put them together. What does this hydrogen do? It splits it into two. And what does this hydrogen do? It splits it into two again. This is the plus plus combination, this is the minus minus combination, and this is the plus minus combination. So you can draw three diagrams. So you can draw supposing I have three protons, what do I do? Each one will split it into two. And then each one, if you draw this, you will have 1, 3, 3, and 1, which will actually be, you can erase. This is what it is. So basically, the tree diagram tells me that I'm going to get 1 of this, 3 of this, 3 of this, and 1 of this. But all this is provided we are looking at equivalent protons. And all this discussion that we have had is based on equivalent protons. What do I mean by that? I simply mean that these three protons are of the same type, and they are coupling with this methylene proton. Both these are of the same type, and therefore they are coupling with this. So at this point in time, we are simply looking at coupling of equivalent protons. A little later sometime, we will see what happens with a non-equivalent proton. What do you mean by non-equivalent proton? Supposing I had, let us say, something like this. How many peaks will I get? 3, because this is not the same as this anymore. This has a chlorine, that has a bromine. Therefore, one type, the second type, the third type. So I should get 3 peaks. How many peaks will this guy get split into? 3. How many peaks will this guy split into? 3. How many peaks will this guy split into? But then earlier we said these two were equivalent in the other case, and therefore there were 2 protons. And how many peaks will 2 protons give you? 3, but provided they are equivalent. Now they are not equivalent. So what will they do? This fellow will first split this into 2. And then this fellow will come in and split this further into 2. You will therefore get 4. If the 2 protons are equivalent, what will happen? This is equal to this. This is split by the first proton. And then the second proton comes and splits it. If this is equal to this, what will happen? These two will actually merge. Right? So you will get something like this. If this distance, which is a splitting because of the proton, if they are equivalent, this will be equal to this, and therefore you will find 1, 2, and 3. But if this and this are not equal, then what will happen? You will get this over here, and if this is smaller, then you will actually see 4 of them. And we call this sort of a pattern as a doublet of a doublet. This is a doublet. And where does the doublet come from? This doublet came from another doublet. In this case, the doublet of a doublet actually collapsed to 3 peaks. And why was it? Because the 2 protons being equivalent, this splitting here is the same as this splitting, and therefore they overlap. At this point, don't get too bothered by this. At this point in time, let us simply worry about equivalent protons. And let's get this point clear, that if I have equivalent protons, I am simply going to get n plus 1 peaks. 2 equivalent protons, 3 peaks. 4 equivalent protons will give you 5 peaks, and so on. So that's all you need to know at this point in time. After we have worked out a few problems with equivalent protons, then I will come back and deal with this in greater detail, maybe on Sunday when we meet again. And then we will start addressing the issue of non-equivalent protons. And if you look at non-equivalent protons, then of course you will see how many more peaks you will get. You get more peaks than you will get for an equivalent proton. But that is reserved for later. As of now, all I want you to know is how do you decide where the peaks show up, and how do you decide into how many peaks it will split if you have equivalent protons around there. That's all I want you to know. And I will ask Kumar to essentially give you problems which will only involve equivalent protons. so that you can figure that out first and get used to analyzing spectra with equivalent protons. You will then look at non-equivalent protons and do problems on that at that point in time. So Wednesday and Friday, Sukman will be here at 5. I will meet you on Sunday at 9 o'clock and we will take it further. And hopefully I will be done with the non-equivalent protons and maybe dynamics on Sunday. And on Monday we will look at ESR, Monday and Wednesday, and we'll stop at that point.